In this video, I'm going to show you how to set up a development environment to work with the Contact Client Server project. So first, you need to make sure that you have the right version of Java installed. I suggest JDK 1.7 so that you match what's in the Ubuntu Labs and McAdams 1.10. And you need to make sure that you have your Java home environment variable set correctly so that Gradle can find that Java installation. So here under the user variables, I've defined a variable named Java home with the path to that JDK. Now I've extracted the Contact Server Client Server project to the temp folder. Here's where I've downloaded it. Here is the folder that contains the project, and I'm going to build it with this Gradle script. So I'm going to open a command window here and type Gradle W and build. The first time you do this, you need to be connected to the internet so that the Gradle script can download the Gradle distribution and also download any libraries that are referenced by the Gradle build script. I've already downloaded that and have run Gradle, so now it's going and running its compile, and it's also running the unit tests. And everything looks good at this point. Next thing you want to do is generate the Eclipse project files by executing Gradle Eclipse, and this will generate the class path and the project. You can see that they're already there, but you want to generate fresh ones that will work for your particular version of Eclipse and the location where your libraries are. Now I'm going to come here to Eclipse and import that project. And I'm going to select this folder and choose to import that. When I do, I'll see the project here, and there were temporarily some errors, but after it's finished refreshing, those errors have gone away. You can see our build Gradle script right here. We can take a look at that, and let's go ahead and run the server. That's located here under source main Java. Here's the contact server, and when we run it in Eclipse, right click, run as Java application, and that should start a local server. Here's the console with the output for the server. You can see that it has started up on port 8080. And at this point, we ought to be able to use a browser to see this message right here. So I'm going to open a little web browser and come to localhost port 8080, and you can see the message appearing there indicating that the server is alive and kicking. Now we can run the client by right-clicking Contact Client, run Java application, and the client sends a request, and the client code actually creates a new contact and adds it to the list of contacts, and so all of that is working just fine. Now what I want to do is spend just a couple of minutes and show you about the unit tests for the server. So in this folder source test Java, we have a unit test class called Contact Service Test, and it has inside it a couple of test methods that are using the this service object right here, which represents the code in the contact server. The service object is defined up here, as a static variable in the unit test. And let me just run this unit test once. I'm going to right click, run as JUnitTest, and we get the green bar, and both of the tests that were there passed. Let's look and see a little more closely about what happened there. We have this contact service interface. This is the one that we built in class together. This is the one that's marked up with the retrofit annotations there. And I have made the contact server class implement that interface so that we can test the server methods directly using our unit test. And this unit test can either test the methods directly, or it can go through the retrofit network API. That's the purpose of this setup before class method. Setup before class, you can see that it has an if statement with two branches in it. Let's look at this branch first of all. Unless you do special configuration, this unit test begins by instantiating the contact server and storing a reference to it in the service variable. And then the methods in the test simply directly interact with that server logic by invoking methods. Here we're calling reset to populate the service with 3 contacts. And here we're calling reset again. For every unit test, you want to make sure that the server is in a known state, and that's what the reset method does. You can browse that code on your own. But now what I want to show you is that we have this additional branch in the if statement that builds a retrofit proxy object to execute the server code by going through a web connection. And this is closer to simulating the interaction between a client and a server. What happens with this branch here is that we actually start up a private instance of that server by invoking the main method. Contact server.main, remember, is this method right here that starts up a server. We started up on a special port number whose port is which is just hard coded in here, 8976. We configure that port number using this system.setProperty call, and then we use the retrofit APIs to build a proxy object and connect it to this service interface. How can we get JUnit to exercise this? Well, the code here is using a system.getProperty call, and it's looking for a system property named server test. If we want to do a full server test here, we can come into the run configuration for that JUnit test, which is right here. And on the Arguments tab, we can set that server test system property to 1 in the VM Arguments section. And now, when we run the unit test, it will launch a private copy of the web server, wait till it's up, and then it will execute the unit test. Notice the timing is taking longer here because now, when these test methods ran, they ran through this proxy object, which talked to the server. Notice that the server shut down at the end of the test. So normally when you're developing and you're doing your JUnit tests, you're going to want them to run as quickly as possible, which means you're not going to set the server test to 1. But if you want a more complete test, that fires up the server and then does the unit tests, you can, which is what I'm going to be doing to your project when I run the unit tests, you can set that server test property to 1. Now the last thing I want to show you is that when you do a Gradle build, all of the output goes into the build folder, and this did more than just a build. It also did some unit tests. Let's look at the output in the build folder. The libs folder contains the compiled code that resulted from the project. What I want to show you now is what's in the reports folder. Under tests, there is a file that you can open in your web browser that shows you the result of the unit tests that were run after the project was built. You can drill down into that package and drill down into that class and see the 2 tests that were run and the fact that they passed. This is how I'm going to test your project. You're going to have a build script that runs these tests. The second thing that I want to show you is that if you run Gradle and type test and then Jacoco test report, this will not only run the unit tests, but it will also generate a code coverage report. The code coverage report goes into a separate folder under the build reports called Jacoco for code coverage. And if you look at that index.html, that gives you a report that shows how much of the code was exercised by those tests. You can see, for example, that the green bar is indicating that 88% of the code in the contact server package was executed during the test. Here you can see that 100% of the code in the contact database class was tested, but a little bit of the code in contact server was not. And in particular, when that unit test ran, it executed the reset and add contact, contact server, and list contacts methods in their entirety, but it did not exercise the code in the home or main or handle exception methods. This gives you an idea how much of your code is being tested by those unit tests. I'm going to look at this to get a feel for how thorough your unit tests are.